Welcome back to another deep dive on the Explainer. Today, we are stepping directly into the shoes of elite enterprise architects. We're embarking on a real, hands-on masterclass, where we'll take on a massive real-world consulting engagement. Our mission? Designing a production-ready hospital information system literally from the ground up. If you've ever found yourself wondering exactly how the pros approach these massive, high-stakes infrastructure projects, well, you are in the exact right place. But I want you to imagine it's day one of this massive project. You sit down in the conference room with the engineering team, and immediately, the rapid-fire technical questions just start hitting you. Everyone is so eager to start building, right? They lean in across the table and ask, hey, should we use Kubernetes for this? Should we be building everything out as microservices right away? And the barrage doesn't stop there. The next engineer chimes in. Well, should we deploy this entirely on AWS, or maybe Google Cloud makes more sense for this? What about Azure? You can actually feel the tension building in the room as everyone starts debating their favorite tech stacks and cloud providers. And the meeting hasn't even officially started yet. Stop. Just stop right there. If this is how your project is starting, you are asking the entirely wrong questions. Ask any experienced cloud solutions architect and they'll tell you straight up, starting a project by picking your technology first is absolutely the single fastest way to guarantee your project fails. To do this right, we need a proven methodology. Today, we're going to cover the tech-first architecture trap, define what a hospital information system actually is, map out our key stakeholders, and break down functional versus non-functional requirements. Finally, we'll lock in the golden rule, business first, architecture second. Okay, let's dive into this with Section 1, the tech-first architecture trap. So, those initial questions about Kubernetes and cloud providers, they're a massive trap. The harsh truth is that choosing technology before you actually gather your requirements just creates immense, totally unnecessary complexity. Deciding on a database, picking a programming language, or locking yourself into a specific cloud provider before you fully understand the business, that is putting the cart miles before the horse. Experienced architects actively avoid picking cloud services before understanding the business, simply because technology is just a tool to solve a problem. Think about it. If you don't even know what the problem is yet, how could you possibly choose the right tool? Moving right along to Section 2, defining hospital information systems. First things first, we need a shared understanding of what it is we're actually building here. A hospital information system, or HIS, isn't just some simple web app. It is this massive, deeply integrated platform connecting nearly every single department inside a hospital. It manages daily operations, sure, but also critical patient care. The sheer scale and the connectivity required across the entire organization are absolutely staggering. Just to put this into perspective, think about the huge number of core modules you need just to make an HIS function. You've got patient registration, electronic medical records, the whole emergency department, laboratory and radiology, pharmacy, billing and insurance, interfaces for doctors and nursing, reporting, administration, appointments. It's like a giant puzzle, and all of these completely different, disparate systems have to talk to each other flawlessly, in real time. It really proves why enterprise architecture at this level is just incredibly challenging. And why must it be flawless? Because hospitals are arguably among the most challenging enterprise systems to design on the planet. We're dealing with strict security, heavy regulatory compliance, and absolute data integrity. But the real kickers? Patient safety and business continuity. Let's be real. If a retail website goes down, a company loses some money. If a hospital information system goes down, lives are actively at risk. This is exactly why a rigorous, deep dive analysis is 100% mandatory before we even think about touching a line of code or spinning up a single server. Which brings us to Section 3, mapping the key stakeholders. Every single architectural decision we make is directly influenced by the users. And architecture is really only as good as its ability to serve its stakeholders. When we map this out, our primary stakeholders include patients, doctors and nurses, receptionists, lab and radiology staff, pharmacists, hospital administrators, insurance providers, system administrators, and yes, even government healthcare authorities. And here's the catch. Each one of these groups has entirely different needs. A doctor needs lightning-fast access to an electronic medical record during an emergency, right? But a government authority? They need highly secure, anonymized reporting for compliance. These incredibly conflicting needs are what will actively dictate our final design. So the crucial point is this. Architecture always starts with understanding who uses the system. You simply cannot design a solution if you don't intimately know the people whose problems you're trying to solve. Empathy for the user, that is an architect's absolute greatest superpower. Let's shift gears a bit. Section 4, Setting core functional requirements. With our stakeholders mapped, we shift our focus to the actual business objectives. Put yourself back in that room, but this time you're sitting with the hospital board. Before drawing a single technical diagram, you have to ask these essential consulting questions. What specific problems is the hospital actually trying to solve? What workflows and processes already exist today? What desperately needs improvement? What healthcare regulations apply in this specific region? What availability targets are strictly required? And what future growth is expected over the next 5 to 10 years? These aren't optional questions, they are absolutely mandatory. As we gather all these answers, we basically split them into two very distinct categories. On one side, we have functional requirements. This is what the system actually does, your visible features and processes. And on the flip side, we have non-functional requirements, which dictate how well the system performs. We're talking things like speed, uptime, and security. Let's look a little closer at the functional requirements we gather for our hospital. These are the tangible, everyday features the staff will interact with. The system literally has to handle patient registration, appointment scheduling, managing those electronic medical records, processing laboratory requests, routing radiology orders, handling all the billing, and generating analytics. These are the explicit, functional actions the software must perform to actually meet the business goals. Let's move to and see how this builds into Section 5, defining non-functional requirements. While the functional requirements define the features, it's actually the non-functional requirements, or NFRs, that dictate your real architecture. Think of these as the hidden behind-the-scenes rules of the game. We are talking about availability, performance, scalability, security and privacy, strict compliance, maintainability, observability, backup and disaster recovery, cost constraints, and operational simplicity. As an enterprise architect, I can promise you that these NFRs will dictate your final infrastructure and cloud choices far, far more heavily than the functional features ever could. Now, what's really interesting here is how you manage these. The ultimate challenge for an architect is perfectly balancing these interconnected priorities. Actually, scratch that. It's more like walking a tightrope. If you increase security through really heavy encryption, well, you might negatively impact your performance. If you demand 99.999% availability, your cost is absolutely going to skyrocket. Architecture is quite literally the art of balancing these competing non-functional requirements to perfectly match the exact business goals we just defined. And that brings us perfectly to our final part, Section 6, Business First, Architecture Second. This is the climax of our consulting journey today, and if you only take away one thing from this explainer, make it this. Non-functional requirements, which are driven entirely by business needs, will always influence your architecture more than your personal technology preferences. Period. Choosing a database just because it's trendy right now, that's a rookie mistake. Choosing a database because it is the only one on the market that meets the hospital's strict compliance, security, and read-write performance requirements. Now that is enterprise architecture. Successful projects always begin with business understanding, not technical implementation. Look at where we are now. We spent this entire time together, and we didn't debate Kubernetes or AWS or microservices once. But instead, we can confidently say, we now understand the business, we understand the users, we understand the goals. Only now are we ready to actually begin designing. Every requirement we've discussed today is the absolute foundation you need. So the question I'll leave you with is this. Now that you finally have the true blueprint of the business, how will you use it to build your first high-level design? Keep that in mind, and we will see you on the next explainer.